Hey guys, how's it been going? This is Jaser. Let's solve a LeetCode problem today. It's 239, sliding window maximum. You're given an array of integers nums. There is a sliding window of size k, which is moving from the very left to the very right. You can only see k numbers in the window, yeah? Each time, the sliding window moves right by one position. Return the max sliding window. What does it mean? Here's the input. This is an array. K is 3, this window size. We need to output 3, 3, 5, 6, 7. So this is the array. This is where the initial window is. So the maximum of this window is 3. So 3. And then we move the window to the right with one step. And then we got still the 3 is the maximum. And 5. We move to 5. 5 is the biggest one. So now it becomes 5. And the next one is 3. This negative 1, still 5. 6 is the biggest one, so it's 6. 7, 3, 6, 7. Yeah, biggest 7. So yeah, let's just first try the naive solution. We just move the sliding window, and then for each window we can just get the maximum, right? So that, what does it mean? We're just naive solution for each window. For each, we will move the window for n times, and then technically it's n negative k, but we need to travel through the items to get the maximum, so it's still linear. And then for each, we will loop the window again to get the maximum, so it's nk. Anyway, this is maybe not the best. Let's first give it a try to get the maximum, to get it right. Okay. So how do we do it? So we need to start from the first element and go to the next element. So my idea is we will use the I, focus on the ending item, ending index, and start popping. Oh, we don't need that. We just start, because for this kind of, we just start from the this index, right? And yeah, and anyway, we will go back and get the items, get the maximum from the within the k steps. Cool. Okay, let's start. So let's end the index, which is I. For that I equals. Okay, that it should be k, like 1, 2, 3. The index is k, yeah. And then I smaller than nums.length. And let's do some quick return here. So if nums.length smaller than k, let's maybe give it a bigger size. Font size, get code editor, font size, maybe 16 is better. Great. Oh, this is too big. Sorry. This is a new UI. It's not cool. Okay, this is maybe better. Okay. Yeah, and here we will return. We need to return an array, right? Just to return empty. And here we just create a result array. Yeah, and then we will just go backwards. So for let k equals I negative k equals I, maybe not. Yeah, and we need it. K is bigger than I think it should be I negative k. Wait a minute. If like 3 is 1 negative I negative 1 negative 2, so it's negative 1 I k negative decrease, and then we will get the maximum, right? So let here we would just let maximum equals nums k, I equals k. Oh, not K, should be J, sorry. It's conflict. Okay, nums I. Okay, then we don't need to start from I. We just start from I negative 1. Great. And max equals math max nums J. And this means we'll just push the result, right? Push the max. And then we can return the result. I think it should work. It's pretty simple. Yeah. Wow. This is a wrong answer. What did it? We are missing one item. Shit, I know what happened. It's not K, it's K negative 1. Great, let's submit. I think it's TLE. Anyway, the times, yeah, TLE. Okay, let's try to improve it. This is a naive solution. Okay. Let's look at the example again. So, for this one, at 1, 3, negative 1, the next item is negative 3. And it's the smallest, so we add it here. Well, it's window, we have to add it here. And next one is 1. We can see that actually we get the same maximum because the 1 is smaller than 3, right? 3 is the maximum. It is smaller than the maximum. So it just to be popped without affecting the next one. Because negative 3 is smaller than negative 1, is smaller than negative 3. So 3 is the maximum. Now we get 5. When we get 5, 5 becomes the biggest one. And now these two will not affect the maximum for the next few windows, right? So you can see for the next one, it's still 5. I mean, if the next one is bigger than 5, then yeah. But this 2 will not affect these 5. So technically, this could be replaced with a 5. So this is an idea. So when we get, let's start with 1. Yeah. And then we get 1, 3, right? 1, 3. Because 3 is bigger than 1, so we can actually replace this 3. And it literally means that actually we don't need this full array to hold 2 3s. We can actually collapse it into a more compact data structure, like just 3 together with its repetition, like 2 3s in this array, right? And negative 1. Negative 1 is smaller than 3, so we can put it in it. Okay, let's just, yeah, let's just use the parenthesis. There's 2 of them. It means there are 2 3s. Okay, I just use the asterisk. It's easier to type. You know what I mean? Okay, the next one is negative 3. So it's smallest. So with this, the biggest one are on the left and the smallest one on the right, negative 3. Right? But now it's only 4 items now. So we need to move one out from the left, which is 3. So we remove one. Right? We move one. It was 1 actually, but now we're removing 3 because it's not affecting the maximum. So here we've already started collecting the maximum is 3. Here when we get negative 3, we move out, so it's still 3. And now we get 5. 5 is bigger than every items here. It's decreasing, but it's bigger than negative 3. Negative 3 is negative 1. It's bigger than 3. So actually, it will replace all of them, and it becomes 3 5s. So now it's bigger. It's 5. 3. Great. The next one, 6. 6 is bigger than 5, so it's become 6. We'll pop all of them and replace just a 3, 6. And the next one, wait a minute, it's 3, 3, 5, double 5. Where is this gonna be 6? Okay, negative 3 and 3. Oh, there's a 3 here, sorry. So it's 3. 3 is smaller than it, so it's 2, 3 now. No. This one. It's 2, 3, 2, 5, and 3 now, so it's still 5. And 6 is bigger than all of them, so it's 3 6s. And the last one is 7. 7 is bigger than all of them, so it's 7, 3. So with this improvement, what we get, for this one, we can easily get the maximum from the left one. You see, it's 3, 3, 3. Because this one is not enough, so we 3, 3, 5, 5, 6, 7. So we don't need to do the another loop inside the window again. Every time we push an element, if it is smaller than the right one, the smallest on the right. So if it is smaller, we just push it. Otherwise, we will keep popping, right? Pop this one and push to the right position to keep it non-decreasing, non-increasing, just decreasing array. You might wonder that does that mean it's still the same time complexity? That's not true actually. So for this one, for 5 here, let's say, when we pop negative 3, it will be popped. It will never come back again. Pop negative 1, this item, it will not be, it will not come back again. So for each item, it will come to this list. Maybe not all of them will come. Maybe, yeah. It will be put into the array and maybe replaced with the right item. And it will be popped naturally, like a sliding window foot, right? Go right, and the leftmost item will be popped, or it will be replaced once. So either way, it will be gone from the array. So it's still linear time. So it won't be like a quadratic time. So for this approach, we can actually improve the time complexity to linear time. But we need to maintain this extra stuff, right? It's space for time. We use extra space to calculate some information. This one, obviously, it's linear space. So it's linear space, linear time. The thing is, actually, we could do even better. What is the meaning of this count? It's actually, like say, it's actually, for this 3, for this 5, let's take this 5 as an example. The 5 is here, right? 5, 3 means actually the distance between the target item to the start index of the window. Let's say the count equals the distance between window left, window star to and the target index. So for example, for this 5, it means, for this 3, it means that this 5 is 3 items away from the start. So 5 here, 1, 2, okay, this one is 3, 3, 5 here, right? Okay. So 5, 3, 3, 5, this one. So this one is 1 item, 2 item, 3 item. Well, the distance actually is 2, but yeah, I think you know what I mean. Its distance is 2, but there are 3 items count from the window, right? So actually, this equals the target index because we already know the start index of this window. We can actually make it even conciser, more concise. Just use this array, use the index to replace the count. So we need to use the array to hold, I would say like a peak. Use the index to hold the peak, like no, not peak items. How should I put it? I don't know how to tell. Give you a name. Sorry for my bad English, but anyway, I would say to hold the important ones. Okay, cool. So let's start from the first one. The first one, is obviously is only one item, so yeah. And then 3 is bigger than 1, right? So we keep track of this index. It's 2. And next one is -1. -1 is smaller than it, and so we keep this index 3. The item is 3, -1. And from here we can start collecting the results. So this one is 3. Okay, so the next one is -3. So 2, 3, 4, still 3. And the next one is 5. 5 is bigger than the 3 items, so all will be popped, and it will be 5. The index 5. Okay, then item is 5 as well. So this is 5. And next one is 3. So we got 5, 6, and it's still 5. And next one is 6. 6 one is bigger than all of them. So the index is 7, and we get 6. The last one is 7, and the index is 8. It's bigger than it, so it's 7. So you see that we can basically get the same. I think this one is more easier to understand, but once we know what's happening, understand this number is actually a distance between the index. We can actually create the same algorithm by both tracking the number and the count. But actually, if we get the index, we can both get the number because we already know the array. We can access the number, and also we can get the distance. Distance is we can subtract the index from with the window start, right? So we can make it even better. So let's give it a try. Here is the same. Now we need to use the array to hold the index. Let's say important indices. Great. So let's for now we will start from let I start from 0. I is smaller than nums.length. I plus 1. Okay, so for each item, we will try to update the indices. Wait a minute. What about a natural pop? Natural pop. Oh, it's the same. We will pop. So here. -1 here. We stop. There's one step missing here. Is for 3 -1. What about natural pop? Let's say here 5, right? 3, 3, 5. This one. If the next one, okay, here. Next one is 3. So we push the index in. If the next one is here 2, 3, 4. 2, 3, 4. 3 -1. What if there is a -4, right? The -4, then we need to actually push these 2 out. So the index we need also like so natural pop we need to check if the index, if we need to pop naturally or forcefully. Yeah, I think this is easier to understand. Okay. Yeah, so for the item, let's say the item equals, if keep put this item into indices array, with put item into array by popping the smaller ones. Okay, so let's start with how should we do it? So while let's top equals, how should I do this one? Top. I think while, okay, if important indices, if there's no such thing, okay, here if or k equals 0, we need to return. Okay, if this one is 0, empty, we just push it. Otherwise, we will keep pop the items, right? No, not push the item, but push the index. And while important indices, length is bigger than 0, and the last item is smaller or bigger or equal. If it is equal, we still need to pop. Yeah, if it is equal to the item, we will pop it. Will pop. So in the end, we can just push the indices. So this one is the same. So while yeah, this one actually we don't need this. Yeah, I'm stupid. Great. So we pop it if the top item exists and also it's smaller or equal to it. We just pop it and then we push it in. Great. So this is push, and we will pop an item, right? This will start from if I is bigger than k negative 1. We need to pop. This is push. Need to pop 1 from left. Also, here's when we need to pop. And how do we pop? As mentioned here, for example, if index is smaller than it, then we do nothing, right? We only pop once it's bigger than it or equal. So if I is bigger than the indices, -1, we pop it. No, on shift, it's DQ, which is shift, sorry. This is sound. Do we need this one? For example, for the first one, it's 1, but it's equal to, we need this one. So let's combine these two. If we should try to pop, and also it is bigger than this one, then we pop it. Yeah. And then we are ready to collect the result. So so this is the result. This is auxiliary. Sorry, let me check if I get the right word. It's auxiliary array. So it's should not be counted as the time space cost. Result, we push. We get this index, and we can actually get the number. 0. Great. I think it should work. Bam! Wrong answer. Okay. Oh, why we get 1? Oh, sorry. Yeah, we should need to collect only when it's ready. So we need to actually keep this one. I should verify my implementation before I ran. If we should collect and also need to pop from the left and collect the result. Okay, we should put this before it. Wrong answer still. God. What's the issue here? Let's verify it. So we start from 0. It will end at the last index. We get the item, which is 1 here. This one is empty array. So we just push the index in it. So it's actually 0. I is bigger than it. No, k is 3. And the second one is 3 because 3 is bigger than the... Oh, I see. So this is index, it's not item. Yeah, this one is my bad. Bam! Still wrong answer. What the heck? I for shift. Okay, anyway. I think here we get the number because it's bigger, so we pop, and this one becomes 1. Now next one becomes 2. I is 2, negative 1. Because we cannot pop, so we just push the index, so it's 1, 2. Now we need to, if I is bigger than the index. Oh shit, this one is the start, so actually it's I negative k negative 1. So it's negative minus k plus 1. Bam! Still wrong answer. Oh god, I'm still stupid. So anyway, so for now, 2. So is this 0? So it is. So we pop? No, actually. Okay, here. 2. I is 2. K is 3. So it's 0. Is 0... Wait a minute. 0... Oh, we should not pop yet. Wait. This is wrong. Oh, it's not. So actually it's different. We should start collecting result from this one. But we should pop after it. So it's actually, if I bigger than this one, okay, start from K. We need to pop it. But if, yeah, man. Bam! Jeez, what's the problem here? Okay, so I is 2 now. 3, obviously we don't pop. And here, I is 2. This one, yeah, we push the 3 in, right? You get 3. And then we go to next one. Next one is I is 3, -3. It's small, so we push it. So it's 1, 2, 1, 2, 3. Okay, now I is 3. Yeah, now we need to pop. And I is 3. 3. This 1. Yeah. 1 is. Wait. If it is the same. Okay, this is the window of. So, oh, it should be bigger than it. We then shift. If it is the same, we don't need to shift. Wait a minute. So, when we shift, it means inclusion. So, oh, I see. This is maybe the cause. Okay, finally. I hope it works. Come on. Okay, great. It works. This is interesting. I think I've done some similar questions before. It's like calculating the histogram. Is it histogram? The name? Histogram. Yeah, calculate the histogram. What I did before is still doing the same, like collapse into rectangles by some length count, and actually it could be packaged into a more concise data, which is the index. This is similar, I think. Yeah, it's pretty fun to solve it. Okay, hope it helps. See you next time. Bye.